rewritten version, expanded to approximately double the length, with correct grammar and a more engaging style. Aircraft wing design is far more diverse than you might ever imagine. Although many of us are familiar with conventional wing shapes on today's commercial jets and fighter planes, there exist far stranger concepts that push the boundaries of aeronautical engineering. Admittedly, we haven't yet mastered a real-life version of the Star Wars X-Wing fighter, but you might be surprised at just how many oddly shaped airplanes have actually made it off the drawing board and into the skies. Let's journey through some of the most innovative and downright bizarre wing designs, beginning with the forward-swept marvel known as the Grumman X-29. In essence, the X-29 was a radical experiment engineered during the intense geopolitical climate of the Cold War. Developed with the combined expertise of DARPA, the Defense Advanced Research Projects Agency, the U.S. Air Force, NASA, and aerospace giant Grumman, the X-29 represented a daring leap into an entirely different world of aerodynamics. This plane flew for the first time in 1984 and was conceived to explore the boundaries of what a futuristic, cutting-edge fighter jet could achieve. One of the most striking details about the X-29 is that it's widely regarded as one of the most aerodynamically unstable aircraft ever built. Simply put, it was never meant to be flown by human reflexes alone. The plane's behavior was so twitchy and unpredictable that a sophisticated digital flight control system was mandatory for preventing it from literally tearing itself apart. The designers accomplished this feat using 3 redundant digital flight computers backed up by 3 analog computers, all correcting the plane's trajectory an astounding 40 times each second. Had the pilot been forced to rely solely on manual controls, the X-29 might have disintegrated in midair before an ejection was even possible. This futuristic and somewhat terrifying configuration often leads aviation buffs to joke, "Who forgot which way wings are supposed to go?" But in reality, the X-29 concept borrowed inspiration from earlier forward-swept wing aircraft, such as the experimental Junkers Ju 287 bomber that Germany built and tested near the end of World War II. Remarkably, that pioneering 1944 prototype did enjoy a measure of success despite its unconventional form. Beyond its wing orientation, the X-29 was powered by a General Electric F404 turbofan engine generating around 16,000 pounds-force of thrust. This provided the airplane with the capability to achieve Mach 1.8, translating to approximately 1,381 miles per hour, undeniably fast for such a radical design. However, the X-29 wouldn't remain the sole example of forward-swept fighter jets. Over in Russia, the Sukhoi Design Bureau introduced a comparable concept in the Su-47 Berkut. The Sukhoi Su-47, developed in the early 1990s, boasted a forward-swept wing arrangement that granted it spectacular agility and maneuverability, thanks to its unique aerodynamics. Even though only one production airframe was built, this jet served as a crucial testbed for innovations that eventually found their way into modern Russian fighters like the Su-35BM and the 5th-generation Su-57. Initially labeled the S-37, this aircraft underwent various naming updates and structural refinements, including a tandem triplane layout featuring canards set ahead of the main wings, plus separate tailplanes. Its aerodynamic trick lay in how the wings would twist under aerodynamic loads, necessitating the use of advanced composite materials that could flex just enough to compensate without snapping. Powered by a pair of D30F11 turbojet engines, the Su-47 achieved a top speed of Mach 1.6, slightly slower than the X-29's Mach 1.8. Nonetheless, the Berkut's unmatched ability to fly at subsonic speeds with excellent agility meant it could undertake abrupt changes in angle of attack or flight path, while maintaining supersonic performance when needed. Although it never went into mass production, it undeniably helped shape the direction of future Russian fighter developments, and the visual impression it made was truly unforgettable. Continuing our journey, let's pivot back in time to the latter stages of World War II, when German engineers were working feverishly on next-generation fighters and bombers. One of the more intriguing concepts to come out of that frenzied period was the Messerschmitt P-101, a single-seat, single-engine jet fighter project. It emerged in response to a dire emergency fighter program intended to bolster the German Luftwaffe in July 1944. Its principal innovation lay in a variable sweep angle for the wings, a design approach that would later evolve into the swinging or variable geometry wings we see on aircraft like the Bell X-5 and the Grumman XF-10F Jaguar. With the P-101, engineers hoped to allow pilots to manually adjust the wing sweep between 30 and 45 degrees before takeoff, thereby finding an ideal balance between high-speed flight and safer landings. While it was never meant to be changed mid-flight, it acted as a crucial testbed for the feasibility of altering wing geometry. Originally powered by a Heinkel HS-011 turbojet, the P-111 existed in a range of paper designs and scale mock-ups, with different versions envisioning either 2 cannons or 4 30-meter Mk-108 cannons, and later proposals included the possibility of mounting multiple air-to-air missiles. Some variations even contemplated 2-seat or twin-engine heavy fighters featuring a V-tail arrangement. However, the end of the war and Germany's subsequent defeat abruptly halted development, consigning this promising project to the annals of what could have been in aviation lore. Fast forward to the 1960s, when shifting military strategies turned the world's attention to a new generation of supersonic jets capable of outmaneuvering radar-guided surface-to-air missiles. The result of these changing requirements was an array of variable sweep designs that moved swiftly beyond mere prototypes. Chief among them was the General Dynamics F-111 Aardvark. Conceived for low-altitude penetration missions, this aircraft was built to excel in both the U.S. Air Force as a tactical bomber and the U.S. Navy as a long-range interceptor, although the Navy's version never fully materialized in the long run. The F-111 addressed a critical problem. An airplane equipped with small, highly swept wings could fly at high speed, but it would need massive runways, or catapults in the Navy's case, for takeoff. Conversely, large wings would be great for short runway operations, but terrible for achieving transonic or supersonic velocity without massive engines and excessive fuel consumption. The game-changing solution became swing wings, variable geometry that let the wings pivot outward for more lift during takeoff and landing, then fold back in during cruising for minimized drag and higher speed. Ultimately, the F-111 used 2 Pratt & Whitney TF-30 turbofan engines, which were advanced for their time because of afterburner technology and improved fuel efficiency. The craft had the capacity to carry a hefty payload of bombs, up to 31,000 pounds, while also maintaining enough fuel for extended range missions of over 2,500 miles. An extra fuel tank in the design granted an additional 1,000 miles, proving just how versatile swing-wing technology could be. Nor was the F-111 alone in adopting variable sweep wings. French aircraft manufacturer Dassault Aviation tested their own approach with the Mirage G series in the late 1960s. The original Mirage G was a single-engine concept, quickly evolved into twin-engine iterations called the Mirage G4 and G8, each designed for both land and carrier-based operations. Essentially, the French Air Force aimed to create a multi-role platform that could serve as both an interceptor against bombers and a tactical strike aircraft, potentially even carrying nuclear payloads if necessary. The Mirage G prototypes had wings that swept forward at 22 degrees for takeoff or low-speed maneuvers and could pivot as far back as 70 degrees for high-speed dashes. Though flight testing showed promise, especially for handling qualities and mission flexibility, the program ultimately lost funding and was abandoned in 1968, leaving behind only a handful of prototypes and a wealth of valuable aerodynamic data. Jumping ahead to the NASA projects of the 1970s and early 1980s, we find the lesser-known AD-1 oblique-wing research aircraft, an unconventional design investigated by the NASA Dryden Flight Research Center, now known as NASA Armstrong, at Edwards Air Force Base in California. The AD-1 was a small subsonic jet powered by a pair of tiny micro-turbo TRS 18046 turbojet engines, each generating only about 220 pounds of thrust. It was, in essence, a proof-of-concept machine. The entire wing could pivot asymmetrically up to 60 degrees relative to the fuselage, significantly reducing drag at higher speeds. At takeoff and lower velocities, the wing remained in a more conventional perpendicular position for maximum lift. While the AD-1 managed around 80 flights and offered compelling insight into reduced aerodynamic drag profiles, it was restricted to speeds below 170 miles per hour for safety and ultimately retired in 1982. However, the oblique wing data it gathered remains a fascinating testament to NASA's willingness to probe the limits of flight. Now let's talk about one of the most visually distinctive concepts in aviation history, the flying wing. Defined by its near-total lack of a conventional fuselage and tail assembly, a flying wing looks more like a huge bat or manta ray than an airplane. Advocates of this design point to exceptional aerodynamic efficiency, expansive internal volume for fuel or weaponry, and naturally reduced drag, attributes highly desirable for long-range bombers. One of the earliest attempts at a flying wing, the Citroën Northrop YB-49I, dates back to the late 1940s. Essentially, it was a turbojet-powered evolution of the earlier piston-engine-based YB-35. The YB-49 flew surprisingly well in some respects, achieving an unofficial endurance record of over 6 hours at altitudes above 40,000 feet. Nevertheless, it also exhibited some worrying tendencies, such as rapid acceleration in dives and a tendency to pitch up violently in stalls. When the second prototype crashed, the United States Air Force decided that the design was simply too risky and opted for the more conventional Convair B-36 Peacemaker bomber. Still, the data gleaned from Northrop's flying wing ventures would later become instrumental in the development of the B-2 Spirit, stealth bomber, decades afterward. During the YB-49's test flights, engineers noted a surprisingly low radar signature, which was quite significant, even though stealth technology was decades from formal recognition. By the time the B-2 took to the skies in the 1980s and early 1990s, computing technology had advanced enough to manage the intense aerodynamic complexities that made previous flying wings so treacherous to fly. Sadly, the YB-49 was also dogged by a series of unfortunate events, including sabotage rumors and structural failures. The final operational prototype met its end in a 1950 accident during high-speed taxi trials, abruptly cutting short Northrop's dream of fielding a pure flying wing bomber. But the basic premise, the advantage of minimal drag, extended range, and the innate stealthiness of an all-wing design, lived on. Throughout aviation history, we've seen no shortage of inventive, experimental wing shapes. Some never left the proposal stage, while others, like the F-111 and the B-2, became cornerstones of modern air forces. From forward-swept wings that defy logic but excel at agility, to the variable sweep concepts that solve the speed versus takeoff lift conundrum, to the radical flying wings that presage stealth warfare, there's always been a desire to break free from traditional forms and explore wild new frontiers of flight. Each success, as well as each failure, taught valuable lessons about how to manipulate airflow, manage stress loads, and keep pilots safe. So, as you think about the future of aircraft design, bear in mind that what seems unbelievable at first glance can sometimes become tomorrow's game-changing solution. Once dismissed as impractical oddities, forward-swept wings might influence the next generation of maneuverable fighter jets. Likewise, new breakthroughs in material science may lead to advanced composites that render variable sweep wings more reliable and less mechanically complex than ever before. And who knows, perhaps one day we really will see an actual X-wing fighter streaking across the sky, merging the best of these unorthodox designs into a single, iconic, and thoroughly futuristic form. Thank you for joining us on this exploration of aviation's wild side. We hope we've broadened your perspective on how aircraft evolve, and how even the strangest-looking planes sometimes yield insights that revolutionize flight. If you enjoyed this expanded dive into unconventional wings, we'd love to hear your thoughts or suggestions for future videos. And if you don't want to miss out on new content, be sure to subscribe and activate notifications so you'll be first in line when our next adventure in aerospace innovation is revealed. Safe flying and stay curious.